Hi, in this lecture we are discussing about the Azure availability. So we'll be basically discussing about the high availability in an Azure. So we are going to learn why a high availability, and we'll be going to see a high availability using a zone redundant web application, and we will be discussing the high availability using a multi-region web application, and finally we will be seeing how we can able to design a application use an entire application for a multi-region. So why high availability? So a high availability describe system that are dependable enough to operate continuously without failing. So what that mean? So if you see this diagram, so there are multiple users trying to access a server one. So that is the primary server. So in case this primary server is being down, then it will be fail over to the server two. So we have a backup over there. So typically an availability as a whole is expressed as a percentage of uptime defined by the service level agreement. A score of 100% characterizes a system that never fail. So this is kind of an active passive mode. So user will be always connected to the primary region. So in case it is been failed, then it is been routed back to the second server. So now let's focus on into the availability zone in Azure. So the availability zone is a unique physical location within an Azure region. So each zone is made up of one or more data center with independent power, cooling, and network. The physical separation of availability zone within a regional limit, the impact to the application and the data zone failure such as large scale flood or a major storm. So if you see this availability zone and their associated data center are designed in such a way that if one zone is compromised, the service capacity and availability are supported by the other availability zone in the region. So in this diagram, you can see there are three availability zone and that are being interconnected using a deserve fibers. Right. So if one of the availability zone is been down, your application can able to still access with the other availability zone. Now let's see then a high level architecture of how we can able to design an application using an availability zone. So if you see here an app, so an application have an app service and a function app and a SQL database and storage as well. So if you see this application, so if you want the application app service need to be distributed to multiple availability zone, then you need to have a premium app service plan, and that to the application need to be having a minimum of 3 instances. So that will be spinning up the app into the three availability zone. So in case your application is being down in one of the zone, still you can able to access the application from the other availability zone. So this application is this architecture is a high level representation of how you can able to design a high available application use a zone redundant option. So now let's see the second option. So before going into the second options, let's discuss about the service level agreement, right? So when you have a single VM, so your SLA is 99.9 percentage, but in case if you put an availability set, your availability is service level agreement is going to improve by 99.95 percentage. And when you go with an availability zone, then your service level agreement is going to be improved 99.9 percentage. So here you basically going to deploy your application to the zone 1, zone 2, and zone 3. So any failure in a single zone will be handled by the other zones. In the similar way, there is another option. There is a regional failover. In case actually your application is being deployed in an East US, and if there is an outage in the East US, still you can able to connect your application from a secondary region. So in case of East US, you can deploy your application into the West US as well. So Microsoft have something called as regional pairing. So it is always recommended to have your disaster as a paired region, because Microsoft will not do the patch update into the similar region. And whenever there is a disaster, the priority will be given to up the either of the pair region. So now let's see the high availability application using a multi-region kind of architecture. So if you see here we have an active region and a standby region. So this architecture is being use two regions to achieve the high availability. The application is deployed to each region during normal operation. Network traffic is routed to the primary region. If the primary region become unavailable, the traffic is routed to the secondary region. So basically you can able to architect this kind of multi-region in kind of three scenarios. That is an active passive scenario, or an uh, active passive with a hot standby, or an active passive with a cold standby, or an active active region. What that it mean? So when you say active passive with a hot standby, the traffic goes to one region while the other wait on a hot standby. Hot standby means the VM in the secondary region is allocated and always running. So in this case, this app service plan is being allocated and it is been still deployed, and it been running. So your traffic will be routed to the primary region, and you will be using an Azure front door to health check of your application. If you are not able to reach your app in the primary region, then you will be routing the app into the secondary region. That is nothing but the active passive with a hot standby. The other option is an active passive with a cold standby. The traffic goes to one region. So in this case, it will go to the active region. The traffic will go always go into the active region, and you will not set up the standby region. In case of the failover in the active region, then you will spin up the VMs or the app service in the standby region and route the traffic into the secondary region. This is a more effective way of doing that. But when you talk about your recovery time and the service level agreement, so how much time your app can wait to fail over to the secondary region, based upon that you can design your application architecture. And the third option is an active active, where both regions are active and requests are load balancing between them. So if you see this, both active and standby regions are being up and running. And whenever there is a load, it is been request is coming, it is been distributed to the active as well as the standby region. So now let's discuss about the our third use case, that is the high availability using an entire application. So here, basically what we discussed in the previous architecture, we use a PaaS offering, that is an app service. So in this, we are going to represent the similar kind of active passive region by using the primary and secondary region, basically using a virtual machine. And when you say about an entire application, you will be having a web tier, a business tier, and a data tier. And your web tier is your front facing application, your business tier will be your API, and your backend will be your SQL. And here it is using a SQL server always on, and it's going to replicate the data from this primary server to the secondary server. And you can see this two regions are being separated out with separated VNet, and this two VNet are being paired using a VNet peering. And you can see each web tier is being load balancer, and the traffic is being distributed using a traffic manager. So this is about the another representation of how you can able to design a high availability application in an Azure. So we can see this practical use case of this high availability application in the upcoming video. So that's all about this lecture. Hope you enjoy this video.